Hello and welcome to the UiPath Computer Vision tutorial. Today, we'll see what computer vision is and when it's best to use it instead of regular selector-based activities. After settling the theory, we'll perform an actual comparison between the two in order to better understand the benefits that this new feature brings. After that, we'll go into detail about how to use the computer vision activities. And finally, we'll take a quick look at some of the best practices in building solid automation workflows that incorporate AI. Let's begin. Computer vision is a new machine learning-based method used to locate screen elements and operate user interfaces. It doesn't require or use the underlying properties of applications, but only the aspect and relationship of various screen elements. And that makes it useful in automating applications exposed through unsupported virtualization technology frameworks. Even if the applications are accessed through a supported medium, such as Windows Remote Connection or Citrix virtual apps or desktops, native automation cannot be achieved unless we can install a dedicated UiPath extension. Other uses include cases when the applications that we're trying to automate run locally, but the generated selectors are not available or unreliable. This is where computer vision comes to help. To start off, we need to install the computer vision activity package. Let's open the package manager. Search for the package and click Install. We can see that the computer vision activities have now become available. Please note that for previous Studio versions, we need to install the package UI Automation 19.5 or later before the computer vision one. First things first, we'll start by adding a simple click activity within our workflow, an activity which you're already familiar with, followed by a computer vision click activity. Now, it's important to notice that the CV click activity is included in the CV screen scope, as we'll get back to this aspect later on during our demo and discuss it in more depth. For now, let's see how this normal click works on our test applications. If we select Indicate on Screen, we can see that in this desktop application, all elements are easily recognized when we hover the cursor over them. However, if we move on to the virtual environment here, we cannot interact with any individual elements on the screen. In the web browser, the same thing happens. We can interact with some elements, but these fields are obviously not recognized because it's just an image. Similarly to the virtual environment, we can see that we get the same level of interactivity in the browser, meaning we can only interact with several elements, but in this case, images are not being recognized. Right, so that was the normal behavior. Now let's see how computer vision handles these applications. We will select Indicate on Screen again, but this time let's try using a CV click activity. All the fields in the application are identified, so there's no difference in that regard. The very same application is open in the remote environment. With the simple click activity, we could not perform any action here. But with computer vision, we can easily interact with all the elements: text, input fields, buttons, and checkboxes. And because computer vision works based on the capability of looking at the interface like a human being, it also works directly on an image in the browser. We can detect which element is a button, a checkbox, a label, and even an edit field. Pretty cool. All right, now that we've gone through the capabilities of the computer vision activities and how they differ from the normal approach, let's see them in action. We'll start with an empty workflow. The CV screen scope activity is the base of all computer vision workflows, as it performs element and text detection in the window that we indicate. The scope activity has two properties for the CV server configuration: URL and API key. Before we can use it, we need to provide a URL for the CV server and an API key to be used for authentication. In our case, we're going to be using the UiPath CV server, which comes by default. Next, we need an API key which can be obtained from the RPA Cloud platform. So, first we need to access cloud.uipath.com and create a new account. Then we go to the Licenses section and copy the Computer Vision API key. This is the key that we're going to use in the CV Screen Scope Activities property. The most important aspect that we should consider is that these two properties are synchronized across the workflow. As a result, if we change these values in a CV Screen Scope instance, they will be changed in all CV scopes throughout the workflow. The text seen here is just an image for our machine, so we have to extract it before processing. We need an OCR engine for that purpose. The default engine used in Studio is Microsoft OCR, but we can pick our favorite out of all of the available ones. Now we'll indicate the application, the remote desktop session window in this case, and by doing so, we generated a selector that is used at runtime to take a screenshot of the application and analyze it. The CV Screen Scope stores the analysis of the window to enable the contained activities to use it. If we double-click the informative screenshot, we can see a preview of that image and the results of the analysis highlighted in blue. Next, we'll add a CV type into activity and select Indicate on Screen by clicking here or by pressing the I key. As you can see, in order to make our selection more visible, everything but the scope dims, thus highlighting the automated window. This is the CV helper, and we'll cover it in more details in a second. But for the moment, the most important aspect is this top part. Keep an eye on it, as it informs you about the current state of the selection and also what needs to be done. Alright, now coming back to our CV type into activity, we'll indicate the field where the text should go. While we do so, Computer Vision automatically selects an anchor, which is displayed in the activity's informative screenshot. Moreover, a descriptor is generated for all CV activities. You can think of it as a Computer Vision selector, having the role of storing the relationship between the target and its anchor. Generally speaking, you don't have to edit it at all. You can simply use the wizard. We can easily modify our target by clicking Indicate on Screen again, and then choosing something different, say this one. You can see that the anchor highlighted automatically, and clicking the field updates the activity with your selection. So, the Indicate on Screen option enabled us to change our selection altogether. Furthermore, we can also edit the current selection by clicking Edit on Screen. We can either choose this option from the hamburger menu, or select the activity to be edited and then simply press the E key. Now, the anchor and the target are displayed, and we can edit or remove any one of them. Let's say that we want to select a different anchor. We can remove the current one. The color of the fields have changed. The red color in this field indicates that the current anchor and target pair have some kind of issue, as the text here indicates. Now that's because now it has no anchor, and there are multiple text fields in our UI. The yellow color shows us the fields that are similar to our current selection, in this case, the other text fields. Those fields are also called false matches, or false positives in technical terms. In the Helper section, we are notified that we need to indicate the anchor, but we've seen that it works, even automatically, so let's try something else. We'll pick a different field, such as this one. Since the On Us check text is not unique, it cannot be used as an anchor on its own. The helper suggests that we use another anchor. We can use as many anchors as we want for an element, but the recommendation is to use as few as possible, just enough to give our selection a unique combination of anchors. So the wizard provides details about the selection and notifies us if anything is wrong. If there is no problem, the fields are colored in green and blue. As a summary, yellow indicates duplicate matches to the currently selected one, and red is displayed if the current target or anchor or target pair is not unique. Let's go back to the indicate mode. If we're not satisfied with the anchor that computer vision is suggesting, we can hold the Shift key while we're in Indicate mode, and this will prevent the wizard from closing. We're then free to edit the anchors as we please. However, keep in mind that after doing this, you will have to save the selection manually by pressing OK or Enter. As a last resort in computer vision, we can also use the Image Automation feature. To do that, we simply need to drag select to draw a rectangle around a unique anchor or target. Make sure that you also include the empty space to the left of the text so that it can differentiate it from the label below it. And it worked. The selection is colored in green, which means that everything is fine. But make sure that you only use this box selection method only as a last resort, as it uses image matching, which has the reliability issues image automation normally has. And the activity was updated once again, and our selection is displayed in the Type Into activity. Let's click Indicate on Screen. Another feature that might be handy at times is the ability of selecting just a part of the text. Let's say that we want to type into this text box, and for the sake of the example, let's say this label is not available. We can use this anchor up here. But we don't want to use the number as well because that will change. So for that, we can select the text just like in Notepad or Word by dragging from the beginning to the end of the desired selection. As you can see, the anchor that we chose is valid for our field. Now let's choose Edit on Screen again to have a look at the CV helper. The top part contains a message area which displays indications. Now there are multiple available actions, so let's briefly mention the use of each one. Firstly, there is the Show Elements option, which when clicked previews all the elements recognized in our selected area. Now this is especially useful for debugging or quickly seeing the quality of the OCR detection. Then there is the Refresh Scope action, which simply refreshes the detection, but we'll cover this aspect in more detail later on. And then Refresh After Delay, which provides a 3-second pause before recreating the detection. Now this is useful for cases when you need to indicate an element that's not currently on the screen, such as behind drop-down menus, or if you need to get the application in the correct state for your process. Relative to enables us to interact with elements which were not recognized by CV, or if you want to click in a certain position in an element. For example, here we cannot interact with the scale slider in any way since it was not recognized. What we can do is use this option, which will click it relative to an anchor. If we just click an unrecognized element, an anchor will be assigned to it automatically. However, if we want to see a preview of the anchor that will be chosen, we can hold click. If you're not satisfied with the automatic selection, you can press Shift and then edit the anchor. Report enables us to make a selection of any unrecognized elements and send it for review, while Help sends us to an online documentation page. We can click Cancel or hit Escape to return to our workflow without making any selection, or OK to save the selection and exit. However, if the anchor for the chosen element is valid, we don't need to click OK, as the selection is automatically saved and closed, just like in the default selection screen. We will now cover an important aspect when it comes to computer vision, refreshing the scope. Let's say that we perform some actions in a certain screen of an application, and then we're led to a different screen. In that case, because the screen changed, we need to add a CV refresh activity in our workflow, or a new screen scope. Why is that? Well, because our first screen analysis is cached in our screen scope, but the refresh action that we're adding will make it perform a new analysis. To demonstrate this, let's use a CV click activity to navigate to a different screen in our application. First, we select Indicate on Screen, and then we choose Withdrawal to navigate away from this screen to a different one. And let's run this workflow. As you can see, it typed the value in the cash in field and then clicked withdrawal, so the screen changed. Now we need to add the refresh activity and then click the refresh icon in order to make it perform an analysis on the new screen. As you can see, a new analysis was performed and the elements of the new screen were recognized. Let's use the CV getText activity to retrieve some data from this screen. For example, the transaction number. We need to store the result in a variable, which we'll call transaction number. Now we can output the number to a message box. So let's enter the variable that we've just created here. Let's choose now Indicate on Screen for the CV getText activity. As you can see, we can now indicate a word, and the anchor chosen for it gets highlighted in green. We can indicate text boxes as well, or even buttons, just like other CV activities. Basically, we can indicate any recognized element, and the text from it will be scraped. When I click an element, a new section shows up in the helper where I can change the type of the text that I'm looking for. By default, for getText, the target is always set to be of the type any text because we don't know beforehand what is the text that we want to scrape. And anchors getType text because it should be a fixed string. Now this concept applies for all CV activities and anchors. The only difference is that for getText, the default target is always any text. All other anchors are by default of type text. For now, we'll have it scrape the transaction number. But before we run this, let's go back to deposit. So the workflow consists of writing this value in the cash in field, going to withdrawal, and retrieving the transaction number. Let's go back to Studio and run the workflow. And here is the transaction number. Here, for example, if we want to extract all this text, including the word transaction, we're not able to do it in the same way. So, let's choose Indicate on Screen, and instead of clicking on one of the recognized text elements, we'll draw a rectangle around the text area that we want to extract. While drag selecting, we see a preview of the anchor that will be chosen for our target area. At this point, if I let go of the mouse, the text we see in green will be the selected anchor. Just like before, I can use Shift to prevent automatically saving and closing. Extracting text in this manner will use OCR, and the result will not be 100% accurate at all times. As a lossless alternative, we can use the selection method, which will give perfect results. But there is a catch. It only works on selectable text, such as text fields, input boxes, and editable text. To do so, we have to change the method property to something other than the OCR default. We can choose to scrape a row or the whole text. We'll go with all for now. Selecting this option triggers a warning to let us know that using this method will only work with selectable text, such as text from text boxes. Going back to the application, I will type a value in the first field. As you can see, the selectable text was retrieved. Now that you've seen how you can build a CV workflow from scratch, let's cover an even more time-saving approach. We will now close this application and open a website containing a form. Earlier, after installing the package, you probably noticed that you had a new option in the design toolbar called Computer Vision, which can help you create workflows at a much easier and faster pace. computer vision can also be accessed by using the Ctrl plus Alt plus A key combination. Please be aware that the position of this button might be different on your machine. Now we'll create a new file in our project. When we press the computer vision button, the recording toolbar appears. It has a settings screen where you can configure the authentication and the CV server. These are going to be the API key and URL properties of the CV screen scope resulting from this recording. This is also the place from where you can configure the Ocr engine to be used. By default, there are 2 engines listed here, but as you'll potentially use more in your workflow, they will appear here. Once ready, just press record and then indicate the window to be automated. In our case, this remote desktop window. This will take a screenshot of the window that we indicated, and all the UI elements will be detected. The selector of the indicated window is used by the CV screen scope at runtime in order to perform the computer vision detection. We can now start performing the actions that we want to have in our workflow. Now, we will perform similar steps to a normal desktop recording. At the beginning, a screenshot of the frame that you've indicated to automate was analyzed. By default, the outcome of this analysis will be used for the rest of the recording. So, if any changes occur on the screen and the image changes, we need to refresh the detection. Now, this can easily be done in the recorder by using the refresh button. This will insert a CV refresh activity in our workflow and will enable us to automate based on this new frame. Whilst in recording mode, any shortcuts that you type will be turned into a send hotkey activity within the final workflow. Now for this dropdown, we want to choose Romania from the list. Easier than scrolling down to it, we can simply press R twice and then enter. Please note that there are 3 exceptions for this. Pressing Escape, F2 or F5 will not be recorded as they have roles in the recording process. Now the drop-down has disappeared, the screen was changed, so we have to perform another refresh. If a text box has an unusual appearance, similar to this one for example, you can't just click it to type into it, but instead you must use the type option of the recorder. Click Relative is useful when you have elements which were not recognized, but you still want to interact with them, or when you want to click in a specific area inside an element. For example, the terms and conditions here are not recognized entirely. We're going to click exactly on Terms. And I'll now refresh the scope since the frame has changed. The Get Text button is used to read text from the screen, which you can use later in your workflow. I'll select the title of the first element as the target. And then press Alt plus Left to go back to the main page and click Submit. Let's save the recording for now and have a look at the workflow which was created. To recap, we have a CV type into activity for the first name field, a CV click activity to expand the dropdown, and then a CV refresh, followed by 2 R key presses. Enter, and then yet another CV refresh. Here, we have the activity that was added with the type option of the recorder, followed by a click on the terms and conditions, and we also have one more CV refresh activity, followed by a CV get text activity. Finally, we have the Alt and left arrow combination to return to the first page. For the get text activity, we will set a variable to store the scraped text. We will also be adding a write-line activity to display it in the output pane. And let's run the workflow. As you can see, it performed the activities exactly as we configured them. Let's go back to the workflow. Now, we're going to cover some useful features that you can use whilst debugging a process. If you check Highlight Elements in the Options menu the next time when running the workflow in the debug mode, each step will be highlighted in red so that you can easily keep track of the execution steps. As you can see, each step in the execution is being highlighted. The second debugging feature that you can use is the CV Highlight activity. If you don't want to highlight every step of the process, you can use it to identify only certain elements. The CV Highlight activity can be used in two ways, either by using Indicate on Screen or by providing a value in the input region. For the first approach, we simply have to click Indicate on Screen and select an element to be highlighted during execution. Now we could also choose an area instead of an individual element. Let's redo our choice for this activity. When using the CV Highlight activity, we don't necessarily need to run the workflow in debug mode. The target is still highlighted when we execute the workflow normally. For the second method, you have to obtain the info of an element which was identified prior to the CV Highlight activity. Now this is done using a variable which will pass this info from one activity to another. We'll now configure this type into activity to save its field info inside a new variable, say first name field. The newly created variable is of type rectangle and it holds the coordinates of the element. We'll then set first name field as the input region for the CV Highlight activity. And that's all. But before we end the video, here are a few best practices to use when automating with computer vision activities. For best results while running processes which are using computer vision, it is recommended that you use the following robot settings in Orchestrator. Login to console should be set to No, and font smoothing should be set to Yes. Error reporting is a very valuable action that you can perform while using computer vision because, based on it, we can improve the machine learning model to ensure that every single element will be recognized in future versions. To see how errors can be reported, let's select Edit on Screen. On a side note, we could do this in the Indicate mode too without a problem. Now, if you remember, the email and phone fields were not correctly recognized as text input because of their out-of-the-ordinary appearance. In order to report these, we can simply click the report icon in the helper, or, even easier, press the R key, which is the shortcut for this. To validate the selection, we can hit Enter. And report successfully sent. So, please report any unrecognized elements, as this will contribute to improving the accuracy of the computer vision detection. As mentioned earlier, since CV has to work with images, we are using OCR engines to locate text on the screen. Not all OCR engines produce the same results, so you should experiment with all of them and choose the one that produces the best result for your case. Another recommendation is to store selectors in variables if there are a lot of screen scopes, in order to avoid indicating it every time, and update everything more easily if needed. To do that, copy the selector, create a new variable, which is called selector in our case, and paste its value in the default column. Now, in some situations, we might need to isolate a portion of the application and work only on that. Now, this approach can avoid some false matches issues and also speed things up a bit. Just make sure that the targeted elements will always be in the search area. So first, instead of clicking the entire application, you can drag select a smaller region. In our case, we don't need anything in the lower region here, so we can surround the area that we are interested in and ignore everything else. If we look at the screenshot, we can see that it only includes the selection that we have just made. And this concludes our computer vision demo. Thanks for watching.